Jacqueline, good morning.
Good morning, sir. Good morning. Good morning.
You can hear me, right? Okay. Let me see the sharing quickly.
Sir, 2 मिनट 5 मिनट रुक जाते हैं. We can wait for 5
Nobody's
minutes.
taking the 8 minute है यार अभी. जयकरण तुम 2 डिवाइस से ज्वाइन किए हो क्या?
हाँ सर, एक मेरे स्टाफ के साथ में.
Okay. Jacqueline, screen sharing is disabled, so you have to enable it. Because when I'm trying to share the screen, it's saying host disable screen sharing. Okay. Now it's good. Yeah. All right. अभी शेयर नहीं कर रहा हूँ. जब शुरू हो जाएगा तब शेयर करूँगा.
नेटवर्क भी नहीं है.
કેમ છો? બપોરે ડિપાર્ટમેન્ટ વાળા મને લઈ ગયા.
Good. Now it's good. Sorry. Dr. Bakshi, good to see you. Jayesh bhai, good to see you.
Shall we start, Dr. Ambuj, or we can wait for 1 or 2 minutes more?
Sure, I think it's up to you. I'm ready. So
We can wait for 1 or 2 minutes, then we will start.
not a problem at all. So see, it's good to see familiar faces, from good old times.
Good evening, Dr. Kusumbia. Unmute, cross, unmute.
Very risky. He's driving and focusing on the phone. So please park the phone. Maybe his unmuting capabilities are disabled as well. I don't know.
Yeah, I think it
तो बंद है
enabled.
That's
ना आ रहा जब आए ना जुना है चोरी है कुसुम्बिया सर एम्स ऑडियो बात है ना और ऑडियो अब क्या कर रहे हो प्रभु सुनो ये सब पहले वाला इसे संभालो फिर रात में होगा तो संभालने का
All participants are requested to mute themselves.
छोड़ो उसके अंदर हाँ ये नहीं सब वापस होते हैं
Okay, so Dr. Ambuj, we can start. Yeah, so I'll start with the short introduction of Dr. Ambuj, and then I'll explain how we are going to. What should be the method of today's presentation and today's talk? So basically, Dr. Ambuj is director of the Research Methodology and Biostatistics Core in the University of South Florida, and his section provides the research support to the faculty and students of the University of South Florida, and he has a lot of long experience of the study and meta-analysis and evidence-based medicines, and he's my mentor. So one of my mentors, I learned a lot from him. And basically, in today's lecture, what we are going to do is we are going to have an interactive session, basically. So it will be question and answer session. And in the first part of this today's talk, Dr. Ambuj will explain his view about the different issues in the meta-analysis, which may crop up during the actual meta-analysis, during data analysis. And then later on, after 20-25 minutes, we will have question and answer session. So through the question and answer session, we are going to learn a lot. Basically, because whatever we want to ask, we can ask directly to him. And during that question and answer session, he will elaborate on the different concepts which are going to discuss in the earlier part of interview and the earlier part of his presentation. So, Dr. Ambuj, you are ready with this?
Sure. Yes.
Yeah. So please go ahead. Yeah.
So thank you again, Dr. Jakaran, for the invitation and to do this talk. And just to give you everyone heads up, right? So we thought about how should we do this. So we did brainstorm, and I told Jay, I call him Jay, no formalities. So I hope it's all good. So I told Jakaran, listen, man, there are so many boring talks, slide after slide after slide. But what are we trying to accomplish here? So we kind of agreed that, look, like in any field, as you do more work, I think you learn a lot of applied stuff and how to solve those problems when you encounter those problems. Otherwise, I think learning in simply for the sake of learning is not very conducive because, yeah, we learn, but if we don't apply, we get stuck in those things. So we never get a hands-on experience of doing things. So what I'm going to do is today, so here is sorry, let me just go to the other screen. Yeah. So if you don't mind, right, I have only one question for interaction, but at the same time, if you're going to use this link, you can on your phone browser, go to this, and if you want, I can put in the group chat also. Just for interaction, if somebody wants to remain anonymous. Otherwise, feel free to raise your hand or interrupt when something is not clear, or if you want to ask any question in between as well. So here is the outline of the talk. Objectives, right? So the main objective of this talk is that, after this session, hopefully you will understand the most common data or summary measures used in meta-analysis. You will hopefully understand the hierarchy of data abstraction, because in a paper, if you extract data for systematic review or meta-analysis, the same outcome might be reported in different ways. So, should we use one or the other? So I will illustrate an example also on that. That's why I'm calling it hierarchy of data abstraction, that if there are multiple options, which option should be the most optimal. And then we will also talk about the tips and tricks because the key principle of meta-analysis is that when you try to pull in using any software, right, any outcome, no matter how it is reported in various papers, it has to be converted into one metric or one summary measure so that we can pool it. So we will talk about, that as well. So here is the outline. Very briefly, you guys must be familiar with the process. We'll talk briefly about data types, and then we go over the hierarchy, and then we'll go over actual data abstraction, and then the conversion, and then we'll take any problem-solving questions or go with Q&A. So that's the outline for today's talk. So data types. Broadly, unless you are in psychology, where we deal with a lot of ordinal scales, in medicine, we deal mostly three kinds. Either it is categorical, so I'm calling, let's say, mortality, dead or alive, is categorical data. Simply, we don't care the time period, etc., but simply is dead or alive, yes and no. We talk about continuous measures. So here I took, let's say, CBC, blood count, whatever you want to measure. That's a continuous data. And then the third kind that most commonly we deal in medicine is time to event. And time to event, again, is same like dead and alive, but it's not only as simple as dead or alive, but also it is important over what period of time. That's why when you look at the papers, they talk about 2-year survival, 5-year survival, right? So jokingly, we talk about that predicting death is not rocket science. We all know there is 100% probability that everyone will die that we know of. But the $1 million question is that when, right? That's what we try to do. So that's why we are going to focus on time to event and not simply mortality. All right. So here is a scenario. This is from a real study. So doing a systematic review, as you all must be familiar, if you have done one, that it starts with a specific question. So here is the specific question for today's session. The population is stage N2-3 nasopharyngeal carcinoma. The intervention is a form of neoadjuvant chemotherapy. So it means that before you do the chemoradiotherapy, you treat them with something and not only after, right? And comparison is simply concurrent chemotherapy and no, neoadjuvant therapy. The outcome or the primary outcome in this particular trial was the 5-year distant metastasis-free survival, which simply means that either you metastasize or you die. Both were considered events, one or the other. So as you know, we added, there is always in systematic review, you have to make a decision that what type of question you have. And for that question, what kind of study design will provide you with most likely to provide you with the most unbiased answer to that question. So as you see, the type of question is a treatment or a therapy question. The most unbiased answer to that question will be a randomized controlled trial. And we exactly got that randomized controlled trial for that. And this is what the randomized controlled trial reported. So there were a total of 186 patients in this trial, randomized controlled trial. And as I said, time to event outcome is the primary outcome in this, which is called 5-year distant metastasis-free survival. Here is the real data that was reported in the paper. So option 1, they report 19 events in the neoadjuvant group, 36 events in the no neoadjuvant group. So, and you know the denominator, 93, 93 in both the arms. Option 2, they report hazard ratio of 0.41 and confidence intervals of 0.19 to 0.87, and a p-value is 0.02. And they also report the Kaplan-Meier curve, or also popularly called the survival curve. That's what they reported. So my question to you is that which option should I use for my data abstraction? So if I have to extract data for meta-analysis, should I use events in total? Should I use hazard ratio and confidence intervals? Should I use Kaplan-Meier curve, or none of the above? So go ahead and, respond to that poll, and you can use the QR code also on the screen to directly go there. Let's see how many people have voted. So only one, guys. If more, the link is in the chat. So in case you didn't get it, but you can use the QR code right here to, scan through your phone, and it should give you a response as well. All right, so 3 people responded. Let's go back to the responses. All right, some people said Kaplan-Meier curve. Okay. Anybody else? So anyone wants to, if you're interested, please, I would appreciate if you could tell me, first, let's discuss Kaplan-Meier curve. Anyone have reasoning why Kaplan-Meier curve and not events in total, or the other option nobody has picked so far of hazard ratio and confidence intervals? Any reason? Anyone?
If you want to type in the chat box,
yeah, you can put in the chat as well. Yeah, okay. Yeah, Dr. Lina Jan said she will type in the chat box. Sure. Because at the end of the day, right, you have to extract, you are at the mercy of what is being reported in the paper, right? So and again, just to give the disclaimer that I'm not talking about if only one was reported, so you have to make the most of whatever was reported. But if let's say all the 3 options are reported there, right, which option should be the best? Or why would you take that option? All right, so I haven't seen any response in the chat box, but let's go forward. But looks like a majority people are saying events and total. So in a way, you are correct for one reason. That is not the best approach. I'll tell you in a moment. But at the same time, Professor Jan said hazard ratio. Fantastic. So I see that, yeah, hazard ratios. Again, I see Daulat Meena, the response was number 3, which is Kaplan-Meier curve, right? So anybody is familiar with how do you take data from the curve and impute in the meta-analysis? How do you do that? All right, we will cover on that. Okay, so here is the right answer on that. So here is the hierarchy. So it doesn't matter. Again, in this case, it's hazard ratio. Some places it will be risk ratio. Some places it will be odds ratio. But how do we address this issue? So remember this. So this is a randomized trial. So we are, if the randomization has worked correctly, the groups will be balanced. However, the current recommendation for analysis of data from the randomized trial is that even if the groups are balanced perfectly, right, that if you have, let's say the baseline, this is survival, so baseline does not apply. But if you think that any variable that might impact the survival, make sure you use that as a covariate and provide the adjusted estimates or adjusted hazard ratio and confidence intervals. So the correct answer is the first option is hazard ratio. If there are two hazard ratios, crude and adjusted, use the adjusted one. If you don't have that, use the events. If you don't have that, or not being reported, use the median survival and the p-value. If you don't have that, then only as a last resort, we try to extract data using indirect methods from survival curve. So that is the right option. Is there a question?
No question. There was some disturbance.
Oh, okay. All right. So that is the main hierarchy. Now, while the hierarchy sounds pretty straightforward, the question is, how do you do that? How do you do that conversion, right? How to make the measures similar? So let's go over that example. So this one, before we go there, let's look at the curve data first, right? So how do you do it from the curve? Let's say the hazard ratio is not, available, for example, right? In this particular case. So from the curve, basically, as you see, these lines that you see, the blue lines that I have drawn, right? And there is a paper by Tierney. Let me show you that. So here it is, and I'll show you the sheet also, how it is done. Here, let's go over one by one, okay? So this is an example for, let's say the hazard ratio in this particular trial, right, is, I think, let me see quickly, guys, it's right here. Let's keep it this way as well. So hazard ratio was 0.41, so I can change here 0.41, and the confidence interval went from 0.19 to 0.87, okay? So if you do simply the log of ln of hazard ratio, you get the ln or log of hazard ratio, very simple. And for the standard error of that particular outcome, whatever that outcome might be, the formula is basically log of the upper confidence interval minus log of the lower confidence intervals divided by 2 multiplied by 1.96. So that will give you the log and the standard error, sorry, log of the hazard ratio and the standard error, which you will need for imputes. You will need to enter that data to pool all the hazard ratios, from, for the meta-analysis. So here is an example I'll show you, as simple as that. So this is from the same trial. So if you have used Review Manager, let's look into that. This trial was by HE 2024, the one that data that I talked to you about, right? So let's say the comparison was neoadjuvant versus no neoadjuvant, and I'm going to, let's delete this outcome and try the new outcome, create that. What are we going to enter, or what kind of data it will ask you, right? So let's delete this and try to add an outcome here. So let's do the add outcome. And here are the options, right? So dichotomous, it means you will need the event and no event. But remember, word's not clear on the screen. So let me see if I can zoom it.
I think there may be some issue with there. It is clear to us.
Oh, okay, so you need maybe a larger screen or something like that. I don't know. Sorry about that. But again, these are the options that Review Manager will ask you, that what kind of data you have. So within this also, there is a hierarchy, right? So when you think about, let's say, time to event data, and you are entering simply events and the total number, in a way that is not accounting for time. It's simply accounting dead or alive. So there is no time incorporation into that, right? So yeah, that's the last resort. What do you do if you have nothing? It's better to have some data for pooling versus leaving it zero. But if option is available, there are two options. Either you do observed minus expected and variance, if that is available, right? In that case, or you use the generic inverse variance method. And for generic inverse variance method, as you will see here, you will need, in this case, for every single trial that you're going to use, you will need the log. It doesn't matter, it's the odds ratio or hazard ratio, that we can change it, in our settings, but you will need the log of the odds ratio or the hazard ratio or risk ratio and the standard error associated with that. So no matter what is the event, there are ways to convert it. And before going into all those formulas, which you don't have to memorize, there is a paper, which is the updated now here. It's called by Tierney. This is one of the famous papers. It was published first in, I think it was 1999 or 2000 something, I forgot. But this has every single possible solution in terms of that how you can convert one metric into another. So you can use that. So those are the two options. Either you need the OE and variance, or you need the log hazard ratio and the standard error. So in this particular case, let's see if we can replicate that. So the data that we have, the hazard ratio or not, because you have to make sure whenever you enter the converted data, for example, in this case, the log hazard ratio and the standard error, you have to also ensure, right, that the conversion is correct. Okay, so let's put study data, he, in this particular case. So based on our calculation, the log hazard ratio was negative 0.89. So let's enter that. And the standard error was 0.388. So 0.388, okay? So if you look at that, we are able to replicate, if you look at the hazard ratio in this, forget about the metrics, we can change later, it's not odds ratio, because number is a number, and simply that's more of like correctly representing the data so that we make sure the outcomes are similar. We can change that later. But you see, we can replicate exactly 0.41, which was the original hazard ratios in the paper, and the same confidence interval, except 1 decimal point difference, because I think it's happened due to the rounding. That's why it is 0.88 and not 0.87, which was reported originally in the paper. Same way for Tierney method. If you use that method, right, all the calculations are there. You can, if you want, let Dr. Jackaran know. We also have a command prompt, software that we built in-house. And what we can do in the command prompt, we have put all the scenarios together to convert. So let me show you quickly the same thing using different means, okay? How do we do that? So here, it's called CalPub. So we have this program where if you have the number of events also, or if you don't have that, right? So let's say I will pretend that I don't have any information of the number of events or number of people in each group event, okay? Denominator. Dr. Ranu, you have a question? Okay. So in this case, again, it's asking you for the odds ratio, but you're going to use the hazard ratio. So I'm going to put here 0.87, 0.41 is the hazard ratio. It will ask you for the constant intervals, which is 0.19, space, and 0.87. And then standard error, forget about that, we don't have it. So anytime we don't have something, you simply enter -999. I'm going to pretend I don't have any number of deaths. And p-value, I'm going to pretend I don't have it, although I have it, right? I don't have the chi-square. But the more data you have, you will get mostly the similar answers. So here, now let's convert it other way around. We got the OE, observed minus expected, and variance through those calculations. So let's go back to our Excel sheet, okay? And let's create here, we have observed minus expected and variance. So the observed minus expected was negative 5.92, and the variance is 6.64, all right? So for the log hazard ratio, odds ratio, or relative risk, the formula is OE divided by variance. So if you do simply OE, observed minus expected, divided by variance in this case, you see the same log hazard ratio. And the standard error, the formula is equal to 1 divided by square root of variance. Okay. So if I do that, I got the same variance or standard error, which I got from the confidence intervals as well. So now you see, I'm just using that example that no matter how the data is reported, right, we will come to the same conclusion of converting every single study, no matter what they report, into log hazard ratio and standard error. And even in the hierarchy, so from practical purposes, right, like I said, if it's time to event data or even relative risk being reported, use the summary measure because you might get some adjusted summary measure, especially when you are dealing with observational studies in a meta-analysis, which is prone to too many confounding and biases. So that's where, we have to be familiar with converting the summary measures, all reported summary measures, into one metric of log hazard ratio or log odds ratio and standard error, so that we can use it for pooling. So OE variance or log hazard ratio and standard error. So that's mostly for either time to event or binary data. We try to use the summary measure to come to the same metric. Last one about the survival curve. So when you go to that paper that I showed you by Tierney, and in the original link towards the end, I'm going to put this link there in the chat as well for people. You go towards the end. So they're trying to explain the same thing what I showed you in a command prompt program, that we have taken the formula from there and converted that. So it's more convenient that every time you don't have to use that. Oops, sorry. Let's click send here. Okay. So in this particular case, right, if you look at, towards the end, let's go there. Sorry. So these are the additional files available there, which has the same explanation, everything, including they have a calculation spreadsheet, which is right here So if you look at, there are various options in this particular program as well. Let me make it bigger. So you can enter the hazard ratio here, confidence intervals as well. Make sure it's 95% or 99%, or you can simply enter the log hazard ratio and standard error of the log as well, which will give you reverse transformation into hazard ratio as well. Or you can, whatever information is available, you enter there, and in the output information, you will get the log hazard ratio and the standard error variance or OE, etc., etc. You can use this sheet as well. However, imagine for a moment, you don't have events, you don't have even hazard ratio reported in the paper. You have only thing reported is some percent, which people report incorrectly, and the survival curve. So what I did from that paper was, here it is, you go into the curve data. Okay, there is a sheet right here at the bottom. There are two kinds of curve data you can use. One, directly the survival curve, or you can use also the curve data with number at risk. Okay, because there are only two ways people report most often in the papers. Just the curve or curve with numbers at risk. So basically, I was showing you the PowerPoint here. Let's make it bigger a little bit. Okay, so you see what I do is I increase the time points, more than what they are reporting. So what we have seen for the accuracy in our own simulation is that even if they report, let's say 12, 24, 36, 48 months, 60 months, 72, and 84 months follow-up, we try to break it into more intervals than simply, keeping their intervals. So as you see, I created 6 months, 12 months, 18, 24, and so on and so forth, right? And for each time point, you draw a straight line, vertical and horizontal line, right? And you try to find the time point on the curve. So for example, 80 and 100, the middle point is 90%, right? So you can break it down into more. And also, there are programs now on the GitHub where you can upload the curve and it will provide the scale for you as well. So there are a lot of tips and tricks which you can use instead of doing it manually, but I'm just showing you the fundamentals which you can use any program or something to do the curve analysis as well. So in this case, simple as that, you draw one line, vertical line, and then you draw a horizontal line. Wherever the curve falls, right, you take that percent, and that's what you're reporting. So let's get back to the curve, sorry, the Excel sheet now. So you see I changed in the option 1 to 0, 6, 12. Normally they start with 12 months, but I broke it down into more intervals. And whatever percent survival was in the experimental group, okay, the first one as you see here, right, in this case, the column D, sorry. And the same thing you're doing for I here, which is the other group, okay? And you put the follow-up time there. And based on that, if you go to the output information, it will show you right here, okay, the log hazard ratio and the standard error along with variance and OE. So as you can see, this is not exactly perfect, okay? But at least in the hierarchy, in absence of any of the data, you can still salvage something from a paper. And we'll talk about later that is it the best method? Should we use it, not use it, when to use it, not to use it? There's a lot of context in that. But one thing is for sure that you can use this indirect method to extract the data as the last result, not as the first result. So, but the bottom line is that we are trying to, use it, when nothing is out there. So we are basically following the philosophy that something is better than nothing. So I see there was a question on government OPDs are always a very good case of how to collect. Okay, that we'll talk later. That's more about, I think, for doing your own observational studies, but this is in context of systematic review and meta-analysis. All right, so this is another option. And same thing, and also whatever data you have entered, you can match it with the original paper, that how the curve looks in the real paper, and does it match or not? That will also show you the accuracy of your extraction as well. So if you look at this curve and this curve, right? So, I mean, it's not perfect, but it looks pretty similar of what we have extracted. So check the accuracy. Another option is to use the curve data. So there and the number at risk as well. So if you see the E column, we are entering that how many patients were at risk at each time point they have measured. But as you see, to get that number of risk, we kind of had to reduce the intervals from this, and that's why it's not giving you more accuracy. The more intervals you have, you'll get closer to the true estimate what we have in the paper. That's why the hazard ratio is 0.63 and not 0.41 in this particular case. So these are the indirect methods of playing. So even when we have the number of events, etc. So for example, you see in this sheet, this was some other project looking at 2 devices for heart failure. In this case, no matter binary data, not even time to event, we converted everything, we pulled everything using generic inverse variance method because, we are trying to use the summary measure. And these are observational studies, so most often they report only the summary. So you cannot rely on simply the events and the total number, because those numbers are very prone to bias because the groups are very not comparable, not even. And that's why for those purposes, we are converting all those summary measures into log and standard error instead of using the events. So for those reasons, it's very important to use the summary measure instead of raw events, especially when you're dealing with observational studies. And like I said, even randomized control trial, if a summary measure is available, please use that instead of using the raw data. So that was in a nutshell, a lot of conversions, and we can go one by one into a lot of different options. But in a nutshell, there are tips and techniques available for conversion, and there is a hierarchy. So follow that hierarchy for extraction, whether it's binary or whether it is time to event. Use the summary measure. That's the bottom line. And there are formulas to convert one way or the other. So go ahead.
Yeah. But when you do all these things mathematically, it looks a bit difficult, right? So in the study, that Tierney's article, I think we have this Excel sheet is there. So if we explore that Excel sheet, it will be a bit easy, no?
Yeah, sure. So I'm saying Excel sheet is there, and let's say what we do always, right? Whenever we find a tip and trick Jekaran, we'd like to convert that into a user-friendly format. So for example, even up to a novice, right, that Tierney Excel sheet looks very intimidating. I will confess, if you asked me 20 years ago when I saw first time, I said, oh my God, there are too many things to change here. But once you do it, it becomes easier. So the key thing is to, do you know what? Be aware. One thing, if you have to take it from this, right, whole exercise is use the summary measure for pooling. Don't try to use events and non-events or something on those lines. All doesn't matter. It's odds ratio, relative risk, hazard ratio, whatever. Use the summary measure. Only go to the raw events or something when you have nothing. And if you are stuck, research, I call, Jay, is a team sport. Don't try to solve everything yourself. So, I mean, say in our case, like Jay, you have written papers, let's say, about sample size, right? Which is one of the highly cited, for example. All right, you don't have to read every single thing, but you have to think about the problem, that what is the best approach to solve that problem and get help. So Tierney is one of those Excel sheets. RevMan has its own calculator as well, where you can, so if you look guys here, where is the RevMan file? Let me find it. Oh, here it is. So if you look here, right, in RevMan, if you click on this, there is a calculator here as well. Okay, so you look at this, right? So here also, if you start entering, for example, constant intervals, etc., it also converts into similar metrics to be used in. So for example, let's try that, right? So if you do 0.41, 0.19, and 0.87, let's say, right, in this particular case, right, it gives you the same conversion here as well, right? But at the same time, I don't see the OEN variance if you choose to use the observed minus expected unvariant. But key thing is there are tools available, but the tool is as good as the human being using it. There is no automation, right? So you have to think through, how do I convert these things? But there are a lot of things available there. So we simply took those options and converted into the DOS program so that everybody can use it by entering the data. And same thing Tierney is trying to do. So this is a little bit simpler as well. But at the end of the decision to what to use, when to use, lies with us. Context is everything, like we say. So here it is. Just quickly, last slide I have. Last slide I have.
Just one line on that. So
yeah.
if I understood it clearly, if we have hazard ratio and CI and SC, then we should use that instead of using the events or survival.
Correct. And so even when let's say the outcome is simply, let's say not time to event. Let's say outcome is mortality, which is simply dead or alive, right? And if the paper reports relative risk, let's say, crude and adjusted, I would still recommend using relative risk to do the same conversion, right? And use the generic inverse variance method for pooling instead of going into the raw data and converting relative risk and all those stuff.
Preferably adjusted one.
Exactly, if it's available, adjusted one, right? And if not, then you have to use the unadjusted one. If not, then you have to take the events and convert that into a log of whatever the summary measure is and standard error to get that. But use the summary measure whenever possible. If not, convert the events into summary measure to pool instead of using the raw data for pooling. That is the last resort, right? Last one, just to cover quickly, that most common questions we see is when we are using continuous variables. So despite all the recommendations for reporting of clinical trials, still there is a major issue in reporting. And not only that, I don't know if you know the name Frank Harrell. He's one of the biostatisticians from MD. He's in Houston, MD Anderson. Yeah. So he runs a blog also. I would highly recommend. He is one of the few biostatisticians also who kind of simplifies the concepts and brings up recommendations on how to handle things at the primary trial level. He does not do it for meta-analysis, okay? So the recommendation always in a randomized trial with a continuous variable, that most people still report pre-post change in certain things in one arm and pre-post change, in the other arm. And that is totally sorry to say this, incorrect way of analyzing data for a comparative study due to various reasons, including regression to the mean. Because the whole purpose of comparison is to avoid the regression to the mean, right? That things will change pre-post. So if you're doing a randomized trial, the assumption anyway is that the groups should be comparable at baseline for whatever we are trying to measure post-intervention. So if you're going to have a comparison of one drug versus other drug for blood pressure, and we hopefully is in hypertensives, right? So within the classification of hypertensives, right, whatever the systolic or diastolic might be, if the groups are not comparable at baseline, it means your randomization has not worked. So the groups should be comparable. So there is no question of pre-post. The pre should be comparable in both the groups. And if they are not, randomization is flawed. So the goal there is to compare, right, the post-intervention scores or blood pressure or whatever that might be in the two arms, right? So from that, right, we calculate the mean difference, not the mean difference pre-post, but the mean difference across the two groups. So you have to understand in terms of methodology that what's going on to make sure that data that you are imputing there follows that method. Otherwise, a number is a number, means nothing, right? Whatever people can report. So as a systematic reviewer, you have to think through that what data I'm using according to the methodology. And in that continuous data, the same tips and tricks, there are not too many conversions per se, except for example, sometimes what happens, some trials report standard deviation, some trials report standard error. Some trial will give you simply the post-intervention means, but no standard deviation. They will give you maybe the interquartile range. But even for that, there are formulas. If you look in the Tierney paper, they talk about continuous, how you can convert from one metric to another to bring everything to the means and standard deviations, for each trial from various metrics as well. And sometimes you make assumptions which could be explored whether those assumptions were correct or not. So for example, the key principle in any systematic review is, or meta-analysis is, the similar studies with similar populations, similar interventions, similar comparisons will produce similar results. Not the same, but similar results, right? So when you simply do a visual inspection of the forest plot, you can see that are the results consistent across the pooled studies or not? And if it's totally opposite, let's say, right, that one favors A and the next trial is favoring B, we have to explore that why that is happening. And we have to come up with our assumptions. But that's again a practical aspect of, addressing, using the context to understand or explore the robustness of your findings. So there is no mathematical formula for that. You have to understand the context, and based on whatever information we have, we are going to explore that why that difference is present in this meta-analysis. So that was in a nutshell about the continuous outcomes. And I had put plan that I can show you, but I already showed before. So I'm just going to summarize and then we'll start the Q&A. So again, summary measures should be preferred over events, regardless of the summary measure type. So it doesn't matter, it's an odds ratio, it's a relative risk, it's a hazard ratio. Use the summary measure. And if the summary measure is available, don't use the raw events and total number of patients for pooling, because that might be considered more prone to less reliable results than a summary measure, especially if two summary measures are reported. Even in a randomized trial, the crude versus adjusted, use the adjusted one. Even when you're using the continuous data, think about the methodological considerations. People might report it wrongly, the results in those trials for continuous variables, but at the end of the day, you will need bottom line, the continuous, the summary measure, which is the mean difference or standardized mean difference, either of those, and the standard deviations in terms of pooling. So that is the key thing. As I showed you, few resources, but there are extensive resources available. But at the same time, those resources do not tell you when to use it. when to use it, that you have to, decide. So bottom line is you have to think through every single issue to problem solve it. All right. So that's the key thing. So there was a question is what to do over the meta-analysis for the phenomenological studies. Sorry, I have no idea what are those studies even. Okay, so if you could explain to me, I can give you a better answer of those. So time for question and answer. So Jay, you wanna read those questions, or how do you want to do that?
Yeah, I'll ask, and if someone else, or like if someone from participant want to ask, then he or she can go ahead. But meanwhile, I'll ask directly through this. So basically, when you were talking about the pre and post data and the continuous outcome, and if it is a large sample size study and randomization is perfect, then both the group will have, all the group will have similar, I mean, not significantly different mean values. But if because of some chance there is a difference in the mean values, and if that may affect the end of the study values, then what to do in that condition?
So two things, right? So because you don't have access to the individual patient data, so because that could be the perfect way to address that would be in a individual patient data meta-analysis, right? That if you have the raw data, you can run some adjusted analysis and calculate the summary measure, which again gets pooled in the overall meta-analysis anyway, even in the individual patient data meta-analysis. But while based on your assumption that let's say the group are uneven for some variable, some factor at baseline, right? They are not similar. Let's say even if you're measuring blood pressure at baseline, it is different. And somehow it happened, right? So anytime you see a trial results, right, there are three explanations. Either the results are, true representation of the effect of the intervention, or the results are, due to just purely good luck, bad luck, which is random error, right? Or the third chance is that results are biased. That's what you are alluding to, right? The results might be biased due to uneven distribution of X, Y, Z, whatever. So the question now is that evenness is the unevenness is, uneven, but is it impacting the true effect or not? That's the key thing we are trying to explore. So I would do first approach is still pool them because again, it was a randomized trial due to just good luck, bad luck, it happened, right? And I hate that word large or small trial because I think there is no such thing. Either it is a powered study or it is not a powered study, right? I mean, what is large? We don't even know, right? So, and then I will explore the forest plots to see that are the results really, really different in terms of producing the effects compared with all other studies? And if that is the case, first I will do a sensitivity analysis to remove the trial to see overall the results remain changed or unchanged. If it's not, I'll put them back and safely we can assume that the results were not influenced by that imbalance, right? Third option, I could do a subgroup analysis and look for test of interaction, because the key assumption is this: whatever we are talking about, Jay, here is that is it going to change the bottom line, which is the results, right? So if the results do not change one way or the other, we can safely assume that despite the presence of this bias, there is no impact of that, and I will still include it and report it transparently to demonstrate that. So it's more of a methodological understanding than simply assuming, which you cannot prove one way or the other mathematically.
So in that case, do we need to take before and after value mean difference, or the end of the study values?
I will still use whatever I have used for all other trials, like post-intervention measures and the standard deviation in the two groups, and compare the mean. The summary measure will be the mean difference across the two groups post-intervention. I will not go back to that, because even if you do that, right, still you have to then convert it, right? If you do pre-post, right, you are introducing a bias, which is the incorrect way of analyzing the data from randomized control trial. So if they already somehow the randomization got messed up, we cannot fix that. All we can do is explore the impact of that, whatever that mess is.
Robert, I can see a question in the chat box. Is it needed to check the quality of the study? What are the different methods to check quality of study in meta-analysis?
So that is very standardized response in terms of what you're calling it quality. The correct word is the risk of bias in those studies. That's what I think you're alluding to. That's what we mean by quality. So if you're going to, so again, remember context of a systematic review, similar studies with similar populations, interventions comparison will produce similar outcome or similar results, right? And then also there is a hierarchy in terms of what is the best design for a particular question type. So if we are going to talk about interventions, right, randomized trials, if well done, quality, risk of bias, right, are supposed to produce the results which are closest to the truth of that or the effect of the intervention, right? So if randomized control trial, there is a Cochrane risk of bias tool. They have the latest risk of bias 2, I think, tool also, which certain changes. Overall, not much has changed. If you're going to use observational, then there is also Joanna Briggs Institute, tool for randomized trial as well, which is much more detailed than, Cochrane risk of bias. Then there are for observational studies. If you're going to within the observational studies, the simplest one is Newcastle Ottawa scale, right? Even for single arm, you can use that if you don't have a comparison group, right? But if you're going to do a systematic review of those studies. So basically, for every study design, right, there is a specific tool which you can use to assess the risk of bias in those trials. But make sure you use the right one, and don't try to pool. Most common mistake people make, pooling randomized and non-randomized design together, which you should not do. Everything should be analyzed separately, not all together. Pooling is not simply mathematical pooling. You have to still understand the context, whether we should pool or not pool.
So I think I'm waiting for few more questions in the now regarding the risk of bias. So do we need to focus on the published paper, or we should also go for protocol of the paper, or supplementaries and clinical trial registry, etc., etc.?
Everything. The answer is very simple to this question. Whenever you do a systematic review, anytime you see, I can show you example after example, people have done wrong things, incorrect things, I would call it, right? The purpose of a systematic review and meta-analysis to synthesize everything. It should never be guided by who has done the study, where it was done, what language it was published, which journal it was published, what was the impact factor. Those, just example randomly I'm giving, that should not influence the decision to pool or not. That is totally flawed way of doing systematic review. So even Jay is unpublished. The goal here as a systematic reviewer is be an observer and put things together without using your brain to judge anything without a valid tool. So there is no guarantee that something is published in a high impact journal, they will do a right thing. And even whatever you call it right, you have to define and explain it and not use the traditional measures of name, fame, institution. So bottom line, sorry, I'm going to use the title of a paper that I recently published a letter. Eminence could not be a substitute for evidence. So you have to take everything. And whether unpublished or simply reported somewhere, blog even, right? Let's say some trial you found, should be included. There is no reason to exclude anything unless proven otherwise based on a specific eligibility criteria.
Thank you. And now next question is related to heterogeneity. So what we used to do at early stage, that first we use fixed effect model, and then if we are getting heterogeneity, then we used to go for random effect model. Now,
no.
What should be the right way of doing it?
So any scientific enterprise, right? Whether you do observational study, retrospective cohort study, doesn't matter what's the design, right? What is science is all about? Science is bottom line observed minus expected, right? So what is expected? We put our hypothesis in a protocol, right? That what we are going to do. So we come up with a study plan, we articulate the same thing we do in a systematic review, right? You articulate every single thing that what are you going to do? And you follow that path. Depending on the data, something, you don't try to change the outcome from primary, secondary. You don't try to change the eligibility because something is not being reported, right? So you have to stick to the plan. So when that is the wrong total information that even the choice of model, random versus fixed effects model, right, should be a priori decided, because most often, again, we know that fixed effects model, right, the weightage of the pooled studies, like how the weightage is done, it is done based on the sample size, right? The larger the study, they will get more weightage. The smaller study will get less weightage, which is not the case in random effects model. We also know the properties that fixed effects model normally produce, more precise estimates, like confidence interval will be narrower. But if you do the random effects, it's going to be a little bit broader, right? So that decision to use the model should not be based on heterogeneity. And now the argument for heterogeneity. So somebody, we were discussing some time ago, I think that is most useless metric ever invented, where people are trying to take it literally and not thinking about the context. So the famous example I use for teaching is that if your question is on the efficacy of apples versus oranges for whatever the health you describe, right? Let's say, of course, you cannot put grapes there, right, in the mix. And I think the trials will not have much heterogeneity if they were strictly on apples and oranges, right? But if your question is about the efficacy of fruits, do I care? Strawberry was there? No. And even if it shows heterogeneity, so what? The key thing, the heterogeneity, is simply telling you the effect is different across the pooled study. That's what it's telling you, bottom line, right? So you have to know the context that why it is happening. And like I said, think about the difference in PICO, right? Population intervention comparison settings, etc. That could be producing something else. If you're going to do in pin code areas in India where only the rich people live, and you're going to study something, of course, it will show very efficacious, like let's say apple or oranges, both, right? But if you're going to do underserved area, right, you're not going to see the same efficacy. And that will produce heterogeneity. What do I do with that? Understanding the context, right? So we can do a subgroup analysis. Hopefully it will reduce the heterogeneity, but there's no guarantee for that, right? Because there might be a lot of unexplained. So bottom line, context, you have to think through, and only you can do is not address heterogeneity, but the issue is explore heterogeneity. And just because heterogeneity is high, it does not mean it's bad or good. No. Context is everything.
Thank you.
So there was a question.
Yes, there is a question by Dr. Shalu. In continuous outcome for example, change in hemoglobin, if study is reported to different time period for change it 1 month, 3 months, etc., how to proceed with this?
So here is the hierarchy again.
No.
Yeah. So to answer this question, guys, so whenever you ask a question, right, you have to be aware of that what is the ideal way to analyze that data, right? So you start from there. If you have an idea that how that data should be analyzed, because this one looks like is a repeated measure, right? So was the question in this trial, the primary outcome could be phrased in this particular hypothetical study, let's say, that we are going to look at a change in HB levels over time or post-intervention, right? Or it could be simply that we will look at 2 months change in hemoglobin levels post-intervention, right? Depends. But imagine for a moment that they are going to do 1 month, 3 months, and more measures, let's say, for example, over a 6-month period measured weekly. So we know the right way to analyze that data, even if you're doing post-intervention means, is to use a repeated measure analysis. So whatever summary measure they're going to report, hopefully that mean and standard deviation post-intervention, right? In the two groups, they are reporting based on a repeated measure analysis. Otherwise, I will ding them for one of the methodological biases and make sure I will run a subgroup analysis to see if the trial effect on this trial differs from other trials because this was a repeated measure and other trials might not be repeated measure. So does it impact or not? So again, I will explore it from a methodological consideration instead of simply treating it as a data issue.
Dr. Amod, before going to the next question, just relevant to this, next question is very much relevant to this first one. If you have trials like 3-month duration, another trial 6-month duration, and then 1 year, so can you pool these trials together in the meta-analysis?
A big principle, yes. You should pool it because you cannot determine the follow-up time. Every trial will have different follow-up time despite having similar outcomes. But I'm pretty sure I will record that what was the range of follow-up time. First, I will report for transparency that the follow-up time was different, right, in these trials. And if I see common things, again, I can do subgroup analysis with similar follow-up time. But until proven otherwise, that one trial is impacting the results so much one way or the other, which we can suspect that this might be due to follow-up time, Because what is the assumption? The intervention might have a very short-term effect or have a sustained effect. That is what we are talking about, right? In a way. Is that true or not? We can explore by subgroup analysis or sensitivity analysis. There is no reason ever I have seen it. Prove me wrong, but I've never seen any reason to remove a trial. No matter, because there are no two patients are alike, no true trial will be exactly the same, right? But whole practice of medicine is based on the effect of average, whether it's going to work in average patient or not. So until we have a quantifiable reason that it might not work here, I will still go for the pool.
And can we do
Until, sorry, go ahead.
and then can we do subgroup based on the duration of trials?
We can always explore it, right? Whatever we have the right to question, right? Which is a very good question. Does the follow-up time affect the overall outcome, right? Because even in controlled situations, we could answer. There are ways to answer that question through subgroup analysis, through sensitivity analysis, right? Using the worst case and best case scenario. There are so many ways, right? But we can explore, but we should not exclude.
Okay, one more question in the chat box, that this is a little bit related to meta-analysis of prevalence studies. So how can we run RevMan, or what effective measures we should?
You cannot. RevMan does not have. You can run only if they're comparing prevalence. You can do that in RevMan, but if it's single arm, you have to use other programs. So there are some free. So again, guys.
I think it can be done in Stata. It can be done R. It can be done.
Stata is licensed. So, but the best resource right now, which is for free with connectivity, is your R.
Oh, yes.
So download R, learn to run R. All kinds of codes are available there for free, which you can tweak it to your needs.
And they are Excel based, no? Meta Excel is there, and Jamovi may also be there. Yeah.
And in this connected world, guys, whatever you want to do, right? You approach somebody and somebody is there to get it done.
Okay. And the question is it mandatory to do subgroup analysis?
Nothing is mandatory. It's all about the context, guys. You have to think through whatever, because there is no per se checklist rule, right? It is all about the context. So again, I'm using a random scenario. If you have only 2 trials, what subgroup analysis we are talking about? You can't do much, right? But if there are 20 trials and heterogeneity is significant, let's say, of course, we should explore that, why it is happening, right? What could be the reason, right? But you don't have to. Again, example that I gave you of apple, oranges versus fruits, right? So even in the fruit case, I don't want to explore. But it's all about putting those expectations, the rules in a protocol, which you have decided before looking at the data.
Okay, Dr. Wood,
so
because we had very less time, so I want to ask as many questions as possible. So we had 2, 3, 4 trials for a question, and what are the situations where we should not go for meta-analysis?
The only time when you cannot go for meta-analysis when you have only 1 trial. That's it. Because anytime, so think about the hierarchy, right? So here it is, I'll give you a real world example, right? That right now we are doing some guidelines, right? Evidence, there is no evidence from comparative studies for some surgical intervention. Forget about that. All single arm, okay? So we have decided a priori that we will not use data from single arm studies, okay? Only comparative study. As you know, single arm studies are prone to regression of the mean, doesn't tell you anything. All you can do is describe. There is nothing to quantify there, right? In single arm studies. So they kept asking, how can we vote for this or that? But they forget one point, right? As a systematic reviewer, you're trying to synthesize all available evidence on a particular topic, good, bad, ugly, doesn't matter. It's as per your definition, whatever you're trying to synthesize. And now coming to the meta-analysis, which you will know only whether you can do or not do after you have done the systematic review, correct? You cannot predict before what you're going to find. Yeah, we do some reverse engineering sometime to look at the feasibility that if there are at least 2 trials to proceed further, right? That could be a practical consideration. But at the same time, the moment you have more than 1, results of 2 studies are better than 1, results of 1 study is better than 0, results of 1 comparative study is better than 100 of the single arm studies. So think about the hierarchy. If you follow the hierarchy, my opinion will be the lowest, anecdotal, right? But if we bring 100 people together and try to systematically put their opinion together, that's better than one person's opinion. So follow the hierarchy that if you have a systematic approach, a synthesis is always better than evidence from a single trial.
Okay, thank you very much. I think we have crossed our time limit. So because we had a lot many questions, but then we will take your help again in future. So the last question actually, Dr. Leena Jain wanted to ask, and this is not related with today's session, but she want to know your opinion. That government OPDs are overloaded with very good cases. How to collect data in routine practice? Any easy tips?
It depends on what you're trying to do, right? So easiest tip is this. I hope, let's go in a hierarchy, right? Easiest tip. So hierarchy, I hope there are some a lot of free open source electronic tools now to collect the data. So for example, paperwork, whatever you're doing, if it's still right there, or it's going into I'm hoping, is it going to a computer center or somewhere? So coordinate with the data team to mine that data, because somewhere it's being entered, I am guessing. But let's say worst case, you have paper data only, right? Everything is in a file, right? Encourage medical students, trainees, etc., to make sure that every day before they leave the clinic, they put at least 5 patients somewhere in an Excel sheet on a PICO question, right? But here it is what happens, guys. So practical tip. At the end of the day, the minimum product out of that enterprise, research enterprise, right, should be, I guess, a published paper or a report. Let's say if we are not going to publish even a report or answering that particular question, right? Whatever clinical question you asked. So it's a very, addictive cycle, right? Success breeds success. So first project that you do where you have a very specified protocol, that is the first step to exciting a little bit whosoever is participating in the enterprise. The more the merrier, right? The more students are there, faster it will be, easier to do, but they also know what they are collecting. And it happens here as well. A lot of faculty, what they do is tell them to collect data and they have no clue why they're collecting, what they're collecting, right? And later on, they're trying to make sense of it. That discourages those students in the future. But if you got 5 students or trainees who collected the data and published it, they will go and spread your word through word of mouth. And next time, people will be begging you that, do you have any project going on that I want to work on this? So I think there is no shortcut to putting your head down and doing it, no matter what resources we have. At the end of the day, everything takes time. So there are no shortcuts. Shortcuts are only this: it saves some time if you have electronic data, which is easy to mine and manipulate, because the maximum time is spent in collecting that data. Analysis, everything is so easy, okay, once you have clean data. So that's where I see the hindrance. So the more you involve as a team and give them results, more likely they will bring more people to your team, and that's how we grow. So that's what, in my experience, happens all the time.
Thank you very much, Dr. Ambuj. Can we take one last question? Because okay. Can meta-analysis be do without systematic review? Happen to read somewhere.
Wrong. There is no other diplomatic answer. A meta-analysis without systematic review is flawed, because simply pooling for example, pooling only good studies, you will see some example. I can show you right now, I can Google and show you, we wrote a letter to the journal, right? Pooling only for whatever reason. The goal of a synthesis, first systematic review, is to assemble all evidence on that topic. Quantitative synthesis is an optional part, but not the other way around. That I did quantitative synthesis, but no systematic. That could happen only in one case. Sorry, I just remember. In individual patient data meta-analysis, because if there are 10 trials, right, 6 investigators refuse to provide the data, what are you going to do? So you have to still deal with the remaining 9, and you can drop one, but you have a valid reason, transparent reason to exclude the trial.
Okay. So basically, we wanted to discuss it for 40 minutes only, but then it exceeded the 1 hour. And we are going to utilize Dr. Ambuj's service, his help in future also. So Dr. Ambuj, thank you very much for your insightful lecture. You have a lot of experience doing such kind of work, and hopefully we are going to remain associated with you in future. So
Thank you.
We have shared the email ID of our Technical Resource Center. So if someone has any question, any participant, they can send their question to us. We will send it to Dr. Ambuj and we'll send you the answers. So Dr. Ambuj, thank you very much for
All right.
being
Hey,
here.
thank you.
And hopefully we're going to have more such lectures in the future. Thank you
No
very
worries.
much.
All right. Thank you, Jeff, for having me. All right.
Good to see
Take care. Bye. Bye.
Thank you, participant. Thank you very much.